So for problem number 4 gives us 3 sequences and it wants to know which one of these converge. So it's important to discern in this case that we're talking about sequences and not series. So to figure out if a sequence converges or diverges, all we do is take the limit as n goes to infinity. So if I go ahead and I look at number 1 and I take the limit as n goes to infinity, well, let's see, what can I do? If I plug in limit as n goes to infinity of natural log of 9n plus 2 minus natural log of negative 9 plus 3n. If I take the limit of that as n approaches infinity, I end up with infinity minus infinity. That's an indeterminate form, so I have to figure out something else to do here. So what I'm going to do is I'm going to take the natural logs, and using the rules of natural logs, I'm going to combine them into one term. So what I can do is I can rewrite this as limit as n approaches infinity of natural log 9n plus 2 over, and I'm going to go ahead and reverse the order here just so I can make it in descending power, just to make it a little easier on myself. So I have 9n plus 2, 3n minus 9. So again, if I take the limit of that as n approaches infinity, it's still indeterminate. Now it's just infinity over infinity. So what I'm going to focus on mostly is I'm going to focus mostly on the inside. If I have 9n plus 2 over 3n plus 9, I'm going to apply L'Hopital's rule just to those terms. So if I apply L'Hopital's rule, I end up with the limit as n approaches infinity of natural log. The derivative of 9n plus 2 is 9. The derivative of 3n minus 9 is 3. So I end up with natural log of 3. Natural log of 3 is a finite number, which means that this first sequence is convergent. The next sequence is negative 1 to the n over n. Again, negative 1 to the n over n would be a conditionally convergent series, but in this case we're looking at sequences, so we're just interested in taking the limit as n approaches infinity. So if I take the limit of this as n approaches infinity, I end up with negative 1 to the n. That's oscillatory, so it's going negative 1, 1, negative 1, 1, so on and so forth. Square root of n is growing larger over time, though. So if the bottom is growing larger and the top is just oscillating, that's going to go to 0. So the limit of that as n approaches infinity is equal to 0, which means that this will be convergent as well. So this one was convergent, and this one was convergent. And again, property for sequences is that if it converges to any finite number, including 0, it's convergent. So here, cosine of pi over n, if I take the limit of this as n approaches infinity, cosine of pi over n, well, pi over n is going to 0 as n goes to infinity, so I end up getting cosine of 0. Cosine of 0 is just 1. So it comes out to 1, which means that that sequence is also convergent. So my answer for this question is A, which says that 1, 2, and 3 are all convergent.
The Teaching Center, UF's Learning Resource Center.